Thank you. Right, let's crack on. So I'm going to be talking today for the next 40-odd minutes about functional end-to-end web apps with SafeStack 5. Just a tiny bit about me, and then we'll move on to the fun stuff. So my name's Isaac Abraham. I'm the founder of Compositional IT. We're an F# centric consultancy and development agency. So we do training, consultancy, outsourced development services, de-risking, all that sort of stuff around .NET, a bit of Azure. I've worked in the software industry for about 20 years now, so development, private sector, public sector, and so on. My focus these days is pretty much exclusively on F# and .NET. Historically, though, I spend a lot of time in the OO world doing C# and some C and C++. But I saw the light, and now I'm one of everyone in this room as well. So just to help me know where I maybe should focus on in this talk, and this is unusual for me because normally I'm giving these kind of talks in the .NET world where I've got to explain to people the value of FP. I assume that's not so important in this room. Nonetheless, I'd be interested to know what people's background is. So just a quick show of hands, who here has done F# in the past? Oh my God. Oh, wow. Okay. That is more than any conference I've ever been to. Anyone not done F# but maybe some other ML, maybe Camel or Elm, Haskell? Yeah, that sort of stuff. Good. Okay. Did anyone go to the Elm talk earlier today? If you did, why are you here, sort of thing? I'm about to talk about some fairly similar topics, but with a slightly different tangent on it. So start with just a basic overview of what is SafeStack. It used to have a really complicated and long-winded sort of description, but nowadays I just say it's the best way to write end-to-end functional first web apps, in our opinion. And that's a pretty strong statement. But we'll go into why we really like it and what it is we think about it. This is what it really looks like. So this is probably the only architectural diagram you'll kind of see. But it's essentially a client-server web app, so both components. So this is where it's maybe a bit different from Elm, which is exclusively in the browser. SafeStack is basically F# on the server running .NET code. And in the browser, it's running on top of JavaScript using a couple of libraries called Elmish and Fable. And we have this kind of message transport in the middle that's type safe. There's some of the challenges and the reasons why we came up with SafeStack, particularly for people that are coming from an FP background and maybe they're not so conversant with JavaScript and, how shall I put it, some of the interesting things about web development today. So things pretty much like what we heard today in the Elm talk, things like configuration and setup is an absolute pain if you don't know what you're doing. It's a fairly high barrier to entry in general. If you've not done JavaScript before, you need to know about architectural guidance, the impedance mismatch, which for me is a big thing, which is you're working on the server and you've got one language, and then you go into the browser and you've got another language and another way of doing things. So that might be JavaScript on the browser, maybe you're doing dynamic typing, you're on the server and then you're doing Haskell or whatever, and it's just can be a bit jarring jumping between these two. The idea of how to do common tasks quickly and easily, dependency management. Anyone here who's done JavaScript and played with NPM, you'll know what I mean. Even things like serialization, I'm fed up of writing apps where you have some DTO on one side and another DTO on the other, and you have to do this boilerplate serialization because they happen to be in different languages and slightly different way of representation. And let's be honest, some of these frameworks out there, they have kind of limited FP support. Maybe you can use some features of functional programming, but sometimes you're fighting against the runtime, fighting against the framework. So we wanted to kind of fix those things. The kind of sales pitch around SafeStack is that, one, it's very productive, particularly if you're coming from a non-web background. You basically have F# on the client, you have F# on the server. All the mapping from client server is done for you. You can share types, you can share functions. Half will be transpiled into JavaScript, the other half will be compiled into .NET. We see a lot of developers that use it say just they find it quite fun and enjoyable because it gives them, particularly compared to JavaScript again, an element of confidence and productivity that they might not have had otherwise. It's kind of important, though, to say that SafeStack is not a framework. And although it's got some opinionated parts to it, it doesn't stop you from changing how it works. It's not as restrictive, whether that's the right way of saying it or not, as Elm, for example. It will allow you to go outside the edges quite easily. And it's more of a collection of libraries that we've bundled together than a framework that we've designed from the ground up. And the last part is that it's mature and reliable. And I'm not saying that other ones are not, but SafeStack is basically running on top of things like React, JavaScript, .NET, Vite, Webpack, basically really big packages and runtimes that have got millions of users today. So that's maybe where it's a little bit different to some of the other functional programming runtimes and so on, where there may be a slightly smaller ecosystem. I'm going to just jump out of the slides for a minute and just show you a demo. When I go back to this slide deck, I'm going to forget to actually start sharing the slides again, so remind me when I do that. Right, let's jump in here. Yeah, we don't want to talk about that book. So this is an app called Safe Search, which is all about property sales. In the UK, everyone is obsessed about the price of property, like nothing else matters. And what this app does is it basically downloads every month the sales that the UK government publish on, I think, AWS blobs as a massive CSV. And we download them, ingest it, put it into a search index, and then we basically let you do some searches. So I can type things like London, and I get some sort of type ahead stuff there. I can hit search, and I'm going to get like results on the right in a grid. I can do things like column heading changes and sorting and filtering and so on. I also get down the left here, faceted search, which is kind of a thing you get like in Amazon, where it will kind of suggest different categorizations for you based on the results. And we can also do things like a little pop-up to show us the property with a map. And I can also do things like a postcode search. So let's do, I don't know, TPJ, and do a search there. So this is now doing it as an area search, and these results are all within, I think, 25 or 3 kilometers or something like that. And I can look at it on a map, I can zoom in and out and get some pop-ups. Nothing completely wild, but you can see that there are different components in there. Also, you can see things like, if you look at the search button, you'll see that I'm getting sort of inline validation as I'm typing. So this is actually doing like a regex to see if it's a proper postcode. And if it is, then happy days. So we've got client-side validation as well. This is not doing postbacks to the server on every key press or anything like that. Right. And behind the scenes, that's just using like, if you've used Azure before, it's like app service, blobs, index search, and a few other services, but nothing unusual that you would expect to see in any cloud provider. The interesting thing is if I look at the GitHub repo, and that's an open source project, you can download the code, that is 98% F#. So there's no handwritten JavaScript. I think the other 1.4% is like a Vite config file and a YAML file and an editor config or something like that. But the rest is just F# application logic. So we'll come back to how that's happening in a bit. I want to focus first on a bit about F#, the language. Now, it sounds like at least half of you have done F#, so this might be just telling you what you already know, but we'll do it anyway. So F# is first and foremost a general purpose programming language. It is not a language designed for maths, science, big data, low-level compute, or anything like that, despite what you may have heard. It's got a functional first type system, which means there are some compromises. It's not Haskell on .NET. It doesn't have type classes, dependent types, existential types, or any of that stuff. It's basically quite similar to Elm in terms of the features it has. it has an OO side to it because it runs on .NET. And that's kind of the rub with running on .NET is you have a huge ecosystem, but you have to have some language features to interop with the runtime as well. I'm just going to give you a very quick primer of the syntax just so you can see what it looks like. So things like, if you've used any ML language, this probably doesn't look a million miles away. So we can, let bindings, there's HM type inference, you have function currying, all the normal things that you'd expect to see. It's got an algebraic type system, so we have product types, so we have tuples and records. Again, it's all inferred. So you can see these kind of gray things here. This is just Visual Studio Code putting in little type hints. That's not me annotating it myself. This is a record. The compiler knows that this is a record afterwards because of the usage, and I can use that with a string interpolation. Has discriminated unions, so we have I can model here direction and some weather and sort of compose them together like I'm doing down here. We also have this feature which I think is more of an F# only one called active patterns, which is kind of a way of putting abstractions and reusable patterns on top of a union. So here I'm saying if ever you see a speed which is more than 10, classify it as high. If it's more than 5 meters a second, classify it as medium, otherwise low. And then I can transparently use it over here instead of actually a specific value. Just like Elm, it's got pattern matching. It also will do things like giving you compiler errors or warnings if you don't handle all the cases, so it has exhaustive matching. Having used exhaustive matching now, I can't believe writing code without that feature. It's beautiful. I think a few languages now have pipes as well. So this is something, I don't know if it was F# that sort of started it off, but it's pervasive in the language, so that's just a way to compose functions together. It also has support for asynchrony, and indeed, if any of you have heard of async await patterns in the past, anyone here? Yeah, so that was kind of this was kind of the forerunner to that. This was kind of the precursor. So in F# you can basically put around your code this kind of task block, and then inside that, you can essentially unwrap asynchronous values. So this method here, getAsync, would normally return a task of HTTP response message. But in this case, we don't need to do that because we have this let bang, this exclamation mark, which is unwrapping the task for us, but only in the context of this task block. So what is this really? Well, we could say this is actually just monadic support. This is the first conference I've ever been to where I've said that, and I've not felt like no one is going to know what I'm talking about. It's brilliant. So here you can see, for example, I have this function divide, which is returning a result, which is either in other languages. So it's either going to return OK of integer or error of string. But inside this block down here, I can use let bang and bang, and it safely unwraps the integer. And if it returns an error, it will fast sort of escape from this block, and it won't pop. So it's essentially bind. Yeah, white space sensitive, we know this, we like it. F# also has null safety by design. There are some edge cases where it's not going to apply, particularly when you interoperate with C# and other .NET languages. But if you're in F# and only in F#, then it's pretty safe. I'm going to jump into the two sort of halves now of the safe stack, and I'm going to look at the different components in it and try and draw some themes around the stack. So on the server, F# basically is running on top of ASP.NET, which is like the standard web server on .NET. Wasn't always the case, but it is today. And the kind of theme I've seen in SafeStack is this idea of having an unsafe platform, essentially. So we've got, when I say unsafe, I don't mean unsafe as in it's unstable, but from an FP point of view, it doesn't quite fit with what we want to do. You've got inheritance, you've got classes, and all sorts of other interesting goodness. But ASP NET is super reliable, it's super fast, it's got a big ecosystem. So we have some libraries on top of that in this case Giraffe, which kind of provides us with functional abstractions on top of this OO layer. And then on top of that, we can use some nice exposed libraries like Saturn, which Chris over there has worked on, which is kind of like Phoenix for Elixir, if anyone's done that. Giraffe, which we'll look at in a minute, and then Fable remoting, which we'll see in the end. What does this functional paradigm look like from F# and like Giraffe's point of view? It's basically saying this. It says that HTTP is just a function. You have a request which has got some kind of parameters, and that can be query string, it can be headers, it can be the body of a post. You do some processing and you give back a response, which is like a response code, some body, some headers, and so on. And in Giraffe, we call this the HTTP handler, which is just a type for a function. And it really says that given any request, you can do one of three things. One, you can say, I don't know what to do with this request, it's not for me. I'm going to give back nothing. Or you can say, no, I can handle this, I'm going to give back something. Or we can delegate to the next element in our pipeline. So Giraffe has this idea of composable pieces where we can plug them all together. And if we look at this syntax, and leaving aside this delegate for now, what this really looks like is something pretty similar to this. So we start with a request to a response, and then we can make that response optional. If we don't know what to do, we give back nothing. And then we push this task effect on as well, which is essentially saying this is asynchronous. And by this composable, here are some examples of what I mean by that. So we could have a root that starts with greet, and that can be a handler on its own. Like if the root matches this root, then I'm happy to pass on to the next one. If the verb is get, I'm happy to continue in my pipeline. And then if I get to this stage, I want to set the response code to 202 and then set the text to hello world. So each of these, you can consider a web application on their own, but you can also plug them together. And that looks like this in Giraffe code. So it looks virtually the same as what I'm describing here with pretty pictures, just as code. And this is an operator that lets you compose these handlers together. I'm just going to give you a very, very brief demo of that. With one I prepared earlier. And it would help if I was in the right folder. There we go. Okay. So this is like a headless API I've got here, which is just about to-dos. Adding a to-do, getting a list of to-dos, completing to-dos. And I've just got some very simple HTTP requests here that I can fire up. So let's just wait until this one works. It would help if I actually had Docker running. Let's try that again. If this doesn't work now, I'm going to start panicking. There we go. Okay, good. So this is just returning some JSON with a list of all the to-dos. Nothing too exciting there. And we can do other ones. We can post a create message. I'm not going to do all of these. I just want to give you an example of them. Here I've got an example of I'm passing in some bad data. So this is supposed to be a GUID in the root, but I'm actually giving just some random text. So it's going to give back a 400 bad request and actually come back with this is the field that's failed and this was what's wrong with it, and so on. So nothing too crazy there. I'm just going to show you what the code looks like very briefly. And let's close this guy down. So we'll start at the bottom, and this is essentially what a Giraffe routing table looks like. So again, the same sort of things that you saw in the slide deck. So we're basically plugging together different small components into a larger one. And then we have this nice choose component or handler, which says, give me a list of other handlers, and I'm going to iterate through each of them until I find one that works. If none of them works, I'm going to give back nothing. So it's kind of infinitely composable in that regard. And the actual implementation of one of these endpoints looks pretty simple. So here I'm calling a database query to get all the to-dos. This is just code gen from SQL, but if I look at the actual SQL here, you'll see it's about as simple as you can get from a SQL query. And that's probably as complicated as I can do. But we're doing things here like getting some results. This is an asynchronous call, so I'm using letBang to get the results. I'm then piping that into my JSON function, which is serializing it, and then I'm returning that response. And it's literally just a fairly simple pattern. The only thing I want to show you on top of this is this alternative way that Saturn provides us with, which is kind of extensions to Giraffe, where I can make this more of a slightly more prescriptive way of working. So this has given me like a keyword that says get, which expects a route, and then the handler. So it kind of is an alternative way of doing this kind of fairly low level. That's a slightly more declarative way of composing your routes together. Right. Okay. So now I want to switch to the browser side of things. This is where things get a bit more interesting. So first question, I guess, is why would you want to do this? Why wouldn't you want to just use JavaScript in the browser? For me, it's kind of a bit of both. Like F# is statically typed. It's got good FP fundamentals. And by that I mean like immutable by default. Everything is an expression. It's got type inference, all very nice. JavaScript, on the other hand, we don't like the language much, but it's everywhere. It's not going anywhere. Despite what the WebAssembly people are telling you, JavaScript isn't going anywhere, in my opinion. It's got a load of libraries. There's new ones all the time. Half of them don't work, but there are lots of new ones all the time. Ultimately, where I look at JavaScript today is more of as a runtime layer. It's more like an assembler for the web, without being called WebAssembly. Again, though, we've got the same pattern. So we have our kind of unsafe world at the bottom, which is things like JavaScript, Vite, Webpack, React, and so on. Things that maybe have some support for functional programming, some not. And then we have this library called Fable, which is basically an F# to JavaScript transpiler. And then at the top, we've got this nice sort of F# functional veneer on top called Elmish. So this is where we start to go back to the Elm talk from earlier on. Where basically we're going to see in a minute that one of the paradigms that we have in F# in the browser is essentially Elm in F#. I'll just show you that one key difference, though, with Elm is that whereas Elm makes it quite difficult, intentionally so, to interop with JavaScript, or maybe we could say it makes it very, very safe, Fable doesn't try and make any walled garden between F# and JavaScript. In fact, it tries to make it as easy as possible for you to call into JavaScript, even if that is unsafe. So it gives you lots of ways of doing that. You can, of course, abstract that yourself. But you can do things like this to just say, well, I've got a function called hello, which I know lives in this module, and the implementation is going to be provided by JavaScript. That's it. You can do things like, here's a function called add, and when I call it, this is the JavaScript I want to emit. So you can actually do fairly low-level stuff like this, crazy stuff. Like here we're adding an integer to a string, which obviously in F# wouldn't make sense, but in JavaScript this is perfectly reasonable. Probably won't give you what you want, but it's totally allowed, and it's like, yeah, well done. Yeah, exactly. Yeah, exactly. Legally unreasonable. And you can even do things like, where are we here? Like this question mark is essentially dynamic member lookup. So it's like fairly low level. I'm not saying you should be doing this, but you can do it if you want, and we don't try and hide that from you. Unlike Elm, where there's like one tool that gives you everything, Safe just runs on top of the JavaScript ecosystem. So you have things like Vite, which will give you things like source maps, hot module replacement, dev server, bundling, minification. Like, if you don't know what these things are, it's an absolute pain to learn. So that's what we try and do as Safe, is to give you these things for free, essentially. Just a very, very quick demo of Fable, just so you can see what it's about. And then So this is just an example of the Fable REPL. So this is the F# compiler that has been transpiled to JavaScript running in the browser. And on the left here, I've just got some standard F# I've written here. So I've got hello world with the city name, and I'm just calling it over here. And you can see on the right, this is the JavaScript that's been emitted. And I'm just going to make it even simpler there. And let's just play this. Yeah, so like this is the basic JavaScript equivalent of the F# on the left. Of course, this sort of thing here that I'm uncommenting now would be legal in the JavaScript world, but obviously in F#, because it's statically typed, you can't do it. So it's kind of erased types in that regard. Like at runtime, it would be allowed. At compile time, it's not. And I can do things like even shell out to the DOM and do things like browser.dom.console, and I get all the types. And that's kind of a package that's been provided with Fable that gives you just IntelliSense over all of JavaScript. And you can see if I save this and run this guy, then suddenly we get a bit more code here. So it's importing some extra types from Fable itself so that we can call some other JavaScript functions in a type-safe or somewhat more type-safe way. But basically, Fable is a very, very low-level compiler. It will just take any F# and emit JavaScript. What you do with that is up to you. So when I'm about to show you this Elmish stuff, that's like a level above Fable. You don't have to use that. There are people that are doing Svelte and all sorts of other libraries with Fable. Okay. Yeah. So once you get to this point, though, of having F# that can go to .NET and to JavaScript, we can start to take advantage of things like server code, where I've done my database access, maybe have some security, whatever else, business logic. On the right-hand side, you've got your React, your UI packages in F#, and then in the middle, you can have shared logic. So there you can have things like contracts of types, maybe some domain types, maybe some validation logic that you want to apply on the client and the server. But you can just write it once in F# and it will be emitted into both platforms. The other thing that's important here is this notion of API contracts. So when I touched at the start on this idea of having one type on the client, one on the server, and then having to manually do serialization, we don't need to do that anymore because it's F# on both sides. And because we own both sides, we can essentially hardwire the connection between the two. So what about the front end? So obviously we've got things like HTML, CSS, and React. Can we really model this in F#? Do you really want to? What about JavaScript, where you're making in-place changes to HTML? So I'm thinking of things like jQuery, which is still being used today, as much as we might like to think it's not. And there are already UI patterns out there, things like MVC, or if you're coming from a .NET world, things like MVVM. The problem is with a lot of this stuff is that they're kind of all based on mutable data structures, particularly some of those patterns like MVC. How do we map that into an FP world in the UI, where we've got all these kind of things that are kind of not necessarily how we might want to model them? And the answer, of course, is another abstraction layer. So here we can have an immutable model on the top, and then an abstraction layer, which in our case is a diff engine that React provides for us, and then a mutable DOM on the bottom in terms of the low-level HTML. And that's what this pattern is that we get from Elm. I think it's called T pattern in Elm. Yep. For some reason in F# world, we decided to call it the model view update pattern because of the nature of it. For those of you that don't know what this pattern is, this is essentially a unidirectional way of actually kind of doing a UI pattern. So you basically have three components. The model, which is your state in the application. So if you were, I don't know, let's say the next Amazon, your model may contain your cart, the items in the cart, your logged in status, what your account balance is, and so on. And then you'll have a number of actions that you can do to that cart. So add item to cart, remove item, empty cart. And you'll have a view function, which will say, given my current model, How should I render that? And then you'll get events from that view. So that could be button clicks, text box changes, which are mapped into these messages. And those then come into the flow right at the beginning again as an update. And the update is basically fold. It says, give me the current state, which is my model. Give me a message, and I'm going to give you a new state. So it's really nothing more than an infinite reduce. Just a worked example of that in screenshots, so saves me from screwing up. This is an example of a to-do application. In F#, all you can do are to-do apps. There's nothing more than that. So this has got an example of like 3 things really in terms of state, or 2 things. You've got a list of to-dos, and you've got a text box, which is the next item that I'm adding. And then we've got a button called add. And you can model that with 2 things. So to-dos, which is a list of to-dos, and the input, which is the string in the text box. This notion of remote data is just an abstraction we include with Safe that essentially says, well, this data isn't loaded initially. So it might be not started, it could be in the process of loading, or maybe it has loaded, here's the data. So it's just a union. And these messages are essentially the actions that you can do. So we can change the input, we can load some to-dos from the server, we can save to-dos. This is another abstraction, this API call, that is essentially request response. So given a string, I want to save this to-do, I'm going to give back a to-do. Now in a more fully featured example, this would probably be result of to-do or validation error. Your update function is essentially as I just showed you before. So message and model gives back another model. So it's essentially the fold pattern. If you're coming from Elm, you're probably thinking, these guys have stolen it from Elm, and that's pretty much true. It's not exactly the same. I'd say it's probably 80% the same. Like there are some bits that we need to do in F# because it's not a domain-specific language like Elm is. So there's a bit of friction, but it's 80% the same, I would say. So pattern matching, if you miss out a case, you'll get a warning/error that you need to fix, the same sort of thing. The view is also very similar to how it works in the Elm world. So here we have a React component, and this is just a function that takes in a list, which is the square brackets of children. And the children are therefore also going to be their own elements with their own children. Because this is just code, the nice thing is that you can do arbitrary business logic or view logic in the code. So here I'm doing a match. Like if the to-dos haven't been started, I'm going to emit a text element. If they've loaded, I'm going to get the to-dos out. And then I'm going to do a list comprehension to actually emit list items for each element, for each to-do essentially. But this is just basic F#. It's like expressions, comprehensions, pattern matches. There's nothing particularly crazy about that. Here we're calling a function. And again, this is just normal F# code, but because it's all emitting data, which is then converted into React elements, you can do what you want here. Right, so the last bit I'm going to do, and I've got, 5 or 6 minutes before questions, is just to revisit where we started and talk about these challenges again. So we spoke about how there's a lot of config and setup, there's high barrier to entry for JS devs, and so on and so forth. We've looked at some individual components. What I want to show now is how that's all brought together to basically solve these issues with this template. So what the Safe Stack comes with is a template out of the box that you can basically, 1-2 lines of command line, you can generate an app that will have all the config and setup done for you. For those of you that don't like this kind of magic approach, we also have a step-by-step guide on the website, so you can build one yourself if you really want to, but I wouldn't bother if I were you. We do all the boilerplate, there's loads of documentation, there's recipes, there's some packages which have like known good dependencies for all the different chains, so you make sure you've got the right stuff. It's F# throughout, and it's not F# that's been Frankensteined in some object-oriented monstrosity, it's just normal functional programming F# throughout the stack. And we also include this this framework called Fable remoting that allows you to just do seamless communication between client and server. So I'm going to try and do this in 5 minutes now. Let's see how far I get. So I've already made a folder, and I'm going to create a new safe app. And once you've downloaded a template, it literally is, or should be, as simple as just typing .NET new safe. Ignore the O thing on the right. And that will create me loads of stuff, but actually it's not too bad. It's basically a set of lock files for dependency management, some tests if you want, and then essentially a client and a server and a shared project. Is that too small for you at the back, or is that okay? A little bit bigger? Better? Yeah, okay, great. So our server project is basically what we saw before, more or less, with back-end code. The client is obviously the front end, and I'm just going to run this now while we're here. So again, one command, .NET run, and that will launch the client and the server in parallel. It will do it through Vite and start the dev server, so you have hot module replacement, bundling, all of that kind of out of the box. This sort of thing just wasn't doable a few years ago in the .NET world because the command line tooling was pretty poor. But in the last 3 to 5 years, it's come a long way. It's now fully cross-platform, so you can run it on Linux, Mac, Windows. It's open source, and it's pretty reasonable in terms of the command line tooling now. So, oh, right. I did exactly the same thing before. So I just forgot to stop the other server. So let's just restart the server here. And then we should be good to go. Yep, okay. So I'm going to just launch the browser and rerun this guy, and hopefully we've got a save up. So this is the same to-do app that you saw before. And I just want to take you through a few bits and make a tiny change, just to show you what it would look like. So you can see this is our backend. It's a really dummy, noddy application to start with. It's just got an in-memory collection of to-dos. It's not using a real database. On the client, though, everything that I showed you before is here. In fact, I took the slides based off this file. Some interesting things here to look at, though, and this is the bit I want to show you, is how would we add in an extra API call end-to-end from client-server? What would be involved? What would the steps be? So here I can add in new items. Let's say by F# in action. But what if I wanted to clear the list out? So I want to try and see if I can do that in 3 minutes. We'll see. So I'm going to start by adding another button onto the UI. So let's go into our code here. So here's our button, and I'm just going to do some good copy and paste refactoring. And I'm going to change that to clear. And if I put this on the side here and hit save, then we've now got our clear button. So this is the hot module replacement that's built in. Interestingly, .NET kind of has this, kind of doesn't. This is one of the nice things about working with the JavaScript world, where anything goes. I want to change the disabled, though, to only show up if there are items in the list. So I'm going to change this logic here to say match model.todos with, and then if it's loaded as an empty list, then it's true. Otherwise, it's false. Get rid of that not. So now my clear button's available. The next thing I want to do is put in a different event. So rather than doing a save to do, I want to create a new message. So I'm going to go up to my messages here and say I want to have clear to-dos of API call of unit to unit, which any good functional programmer knows that's a terrible thing to do because it's basically just saying side effects there, but that's what we're going to do because I'm not in academia, I can just hard code whatever I want. And then we're going to get a warning here, so it's saying I've got incomplete pattern matches. Oops. Got 5 minutes? Yeah, cool. I think I should be okay. I'm going to generate a match for that. And let's see how we get on here. So I'm going to say match message with, and on the start, I'm going to do an API call. And this is an API call that doesn't yet exist, but I'm going to make it exist in a minute. I'm going to call it clear to-dos, which takes in nothing. And on finished, I'm going to say, thank you, Chris, for Copilot. Okay, so what I'm going to do now is I'm going to just move this guy to the side, and I'm going to get my shared file as well out. So this shared file is one that is kind of living between both client and server. So this has got our shared types and our shared contracts. So this bit down here is all the functions I can call from the client that are being implemented on the server. There's no JSON serialization needed. I just have to create this contract. So I'm going to say here, clear to-dos, which is unit to async of unit. And then I'm going to save that. And then let's just close this guy down and see what's happened here. Clear to-dos. That should have been okay. What's wrong here? API is this, and then it's model with to-dos equals loading, and we're going to return back our API call. And I know I'm jumping around a little bit here, but the point I'm trying to make is if you know what you're doing, you can sort of create new functions quite quickly without really getting involved with the usual sort of serialization things that you would otherwise do. So I'm just going to have that as return 0 for now. Let's do to-dos storage.todos.clear. And hopefully, if I restart this guy now, I'm just going to reload this. So let's see if we can add, and then is everything working there? Let's see, that looked good. Ah, well done. Full marks that person. Well done. That's why you come to a functional programming conference. So let's quickly zip down there and just change this guy to clear to-dos, which is going to be well spotted. Start. There we go. So let's try that again. Hey, there we go. So that's like fairly simple, but you can see there was no JavaScript, it all just worked. 2 minutes, okay, good. Right, I'm just going to really quickly wrap up, and then we can probably not take, we might have time for one question. So very quickly, Safe Stack GitHub IO, that's the home page, you can look there. We've got docs, there's plenty for you to see. There's recipes, all sorts of things and goodies there for you to have a look at. Last thing, buy my book, or if you want, I've got, I think, 5 voucher codes for a free ebook of that, and I've also got some like half price. So if you are interested in learning more about F#, I talk a bit about SafeStack in the book. Come see me afterwards. Otherwise, you can always catch me on Twitter, email. Any questions?
Thank you for that. We can accommodate one brief question. So first come, first served.
Hi, awesome talk. I want to ask you, because I'm totally bought. I'm ready to preach the gospel of the monadic church, but my teammates may not be. And with every C# version that comes, more and more F# features are siphoned in.
Yep.
So it's kind of a bad pitch to say to them, hey, here's F#. It doesn't have the stuff that you want to use.
Yep.
But I don't want you to have them. So what would be your elevator pitch to sell F# to a C# company?
How much time do I have? There's 4 posts on our blog, but in short, don't tell them C# is rubbish. that will just get them on the wrong side. The better thing I think to say is, if you like the new stuff that's coming out in C#, all the new features, you like the records, you like the list collection syntax, you like link, F# is that without the other crap, basically. That's probably the better way to sell it.
And here the elevator stops.